Welcome everyone. So welcome to the first general meeting for the HCAA in Canberra. I hope everybody's well. It's a shame that we didn't make our first one, which was in March due to COVID, but here we are online. Hope everybody can hear me as well. So thanks to all our affiliates. So for a bit of background, affiliates are sponsors of the HCAA and also members. They have the opportunity to share their products in booths generally on the side at actual physical meetings, but welcome and thank you to them. We also have industry associates, so they're government or utility operators or technical regulators or similar that also partner and share. So corporate members, also thank you very much to our corporate members. So corporate members have the right and the opportunity to use the HCAA logo on their drawings and material, and also the opportunity to advertise on the website. So I'll just turn my phone off. So for tonight, general meeting opening, committee report and industry updates, and then we'll close the general meeting. Then we'll fire off some topics. First topic will be trade waste from Icon Water. Sharon will present that, and then we'll do some Q&A. Hot water circulating systems using smart pumps, variable speed driven. So Pat and Nick will cover that. I forgot to quite change this one in its total, but Colin's presenting air valves and how we can design air valves into systems, which are now a DTS requirement in the latest ASNZS 3500.4. So committee report by Nick, which I'll jump on to doing. So members of the HCAA get provided a prescriber number. That number sits on their certificates. There's two styles of certificates. One just to identify that you're a member, and the other to identify that you're CPD compliant, which is recognised by some local government and also some regulatory bodies for certification. So what have we been doing since July? So the HCAA have been working with an engineering diploma for hydraulics, and we've provided some updates on that. The public comment for the ASNZ 3500 series is now closed. The Diploma of Hydraulic Services, which is basically run in New South Wales now, as the other states and territories have sort of closed their opportunities, is looking for people to write material for that. So if anybody would like to put their hand up for that, Nick could definitely put you in touch, or Rod Ware, who sort of deals with the education side from the HCAA, would be able to put you in touch to do that, or drop a note in the chat channel, and Em can bump that across to the guys. So education update, IPLEX update. There's also a bit of a interface between CIBSE, which is a Chartered Institute of Building Services Engineers, and the HCAA. So we can touch on where we're at with that. Pump health, education, and a few other items there. One of the interesting ones at the moment is the ABCB's seeking expressions of interest for sanitary plumbing and drainage pipe sizing, and they're looking to pull together a verification method there. So CPD is a big thing. The HCAA is keen on training and providing access to training with ease. So to become a full CPD member, you need to carry 25 points. They're in it for a year. They can be quite easily acquired by attending the lunchtime presentations. So out of interest, these are some of the presentations that are coming up. They're free to join and sort of run during lunchtime between 12 and 1 via Zoom. So provides everybody with a good degree of flexibility there to attend. iPlex has unfortunately pulled out of manufacturing UPVC fittings in their South Australian plant. So just a general update there. Performance solutions. So performance solutions are an important pathway for demonstrating compliance with either the BCA or the PCA. If we're not going down a DTS provision pathway, or if we're using a mixture of both DTS and performance solution. So the HCAA have put together some templates for industry use at no cost. So I think they cover box gutters, valley gutters, eaves gutters. There's one for drainage in reactive soils that will be released shortly. And I think that there might be another one and I can't quite remember, but free to use for anybody. So jump on the website under the Performance Solution Template tab, and you'll be able to download those and use those templates on your next project. So the Diploma of Engineering for Hydraulics starts in 2021. It was programmed to start a little bit earlier, but it was delayed due to COVID. So this will be available to all states and territories by either person or online, which provides a good degree of flexibility. Any information on this, once again, in the chat to Em, or we can pass on Rod Ware's details, or it's education@HCAA is the email address. Framework for Building Practitioners discussion paper. So at the moment, Nick is sitting on a few different committees throughout states and territories to sort of develop up framework in relation to qualifications, minimum experience and the like for practitioners to sign off and certify designs in accordance with the BCA or PCA. So there's a few changes to New South Wales legislation, and then this is some federal work that the ABCB are looking to implement. At the moment, it's open to discussion. One of the strange things across all the legislation is they seem to have differing requirements for education. Some require up to a master's degree to sign off performance solutions, and others only require a diploma of engineering to achieve that. So I think if you want to either raise directly or raise through the HCAA, feel free to either have a chat to Nick and give him a call, or send him an email, or once again pop something in a chat and we can get in touch. So Nick put this interesting slide together just to sort of identify the differing levels of education and qualifications for plumbing designers and also plumbers as well throughout Australia. So I think for licensed plumbers in the requirements sit at a certificate 4, which means that you can do a level 2 certification, which is an up to 6-story building, which would not be classified as a complex building if that classification falls into place. The next level would be plumber designer level 1, which means that you can design to the deemed to satisfy provisions. But as we all know, the DTS provisions are limited basically to classification 1, 2, and 5, very, very small, before it sort of leaves the realm of the DTS provisions. A bachelor's degree, or I believe potentially higher, will be required for any performance solutions, and will give you free range to sign off any style of building. I think that's probably where some discussion needs to be had, and the industry assist to say, look, a lot of people sit at a diploma or an advanced diploma level, or might have you know, a master's degree. So a little bit of flexibility there would be good to ensure some additional pathways for people. So as part of the training initiatives the HCAA have taken on, they've put out a cadetship, an expression of interest. I think that there were maybe 22 applicants. So Rod had the tough task of picking the best 3. So congratulations to Jacob, Peter and Ty. Kindly enough, the AGA and Ream and some other affiliates provided some kit that Rod's delivered to the 3 winners. So congratulations again, guys. Very well done. So as I mentioned earlier, the drafts were out for comment for the ASNZ 3500 set. The drafts are still available. Comments at the moment have closed, but if you do have any further comments that you might not have got in, Nick or David do sit on the standard committee, so I'm happy to represent those on a committee level. Not saying that moves it anywhere, but it does at least get it raised. Great new app for Watermark. So they've moved their database onto cell phones. The good thing about the Watermark search is if you don't find it on the iPhone, is that it either is a non-conforming product or a product that has an exemption, so you can then double check on the website. So very, very handy. You probably noticed that water meters, only 15mm water meters are watermarked, which is quite interesting, noting that the property boundary meter in most states and territories doesn't need to be watermarked because it falls outside of the scheme. So this is one of Nick's favourites, which is a Dodgy Photo Award. I'm not the biggest fan of the music. Okay. So this was a winner. This was an engineer at ACOR at a nursing home, just testing the thermal shutdown ability of a thermostatic mixing valve.
Can you maybe turn on the hot and cold? Hot on, cold on, in our position. Tap not running.
So a bit of an error there. So congratulations, Steve. Feel free to send in your dodgy photos because they're always a bit of fun. Inquiries at HCAA will pick those up for you. So that's the formal part of the meeting closed. We'll now move into the hot topics this evening. So first topic is presented by Icon Water and Shannon and provides some technical advice. So I'll hand over to Shannon. If you like to pop any questions in the chat, and we can address them. So hi Shannon, how are you?
Well, thanks. Hi Tom, thanks for inviting myself, representing Icon Water tonight. I will just try and start the screen share. Okay, hopefully you can all see that.
Yeah.
Great. So tonight I'll just take up a small amount of your time, I guess, and leave some time for questions and answers at the end. I wasn't quite sure the audience that was going to be here this evening, so I've sort of taken the liberty just to do a little bit of an overview of trade waste in the ACT, trade waste management, and then a couple of just common queries that we're getting of late, and then we can launch into some discussion. So yeah, that's the overview as I just explained. So basically, who are we? Any opportunity I get to talk to an audience, I like to remind us here in Canberra that we are now Icon Water and have been for a while, that meaning that we just look after the water and sewage services here in Canberra. We are no longer affiliated or no longer share services with the electricity and gas, so completely separate entity. And own and operate the water and sewer services. Interesting little thing though, I thought that you might all be interested in terms of water. Our combined dam storage here at the moment is back up to 83.6% as of this week, which is fabulous news. It got right down to 45.8 earlier in the year. So I think we're in good stead. With some more rain forecast, we should be in a good place to hopefully avoid some tough water restrictions, so positive news ahead. So briefly, just what is liquid trade waste? I'm sure you all know, but it's common that it gets forgotten that it's basically any activity from commercial enterprises entering the sewer system. So including things from industrial, which we don't have a lot of here in Canberra, which is fair to say, but we do have cement works and those sorts of things, through to community services, so hospitals, schools, commercial, including service stations, hairdressers, those sorts of things, and then animal facilities, sale yards, race courses, and of course we also accept night soil, so basically septic waste delivered to our receival facility here in Canberra. So yeah, anything other than domestic wastewater, basically. The regulatory framework here in Canberra, I've just listed here just some. Obviously there's a whole raft, as you are all aware, but these ones are the main ones related to liquid trade waste management. So we've got Utilities Act, Utilities Technical Regulation Act, of which under then sits the service codes. Guidance that we use is the Australian Sewage Quality Management Guidelines that WASA have written back in 2012, and they're, I believe, being reviewed as we speak. Obviously the Australian standards, of which you've just spoken through and look like are going through a review and update as well. And obviously we have our Icon Water requirements, so the liquid trade waste policy and the liquid trade waste acceptance guidelines. So procedural information, so just sort of high level, here in Canberra, our agreements, our contracts are with the property owners, so not the tenants, not the businesses, not the shop owners, but the owners of the property. So that's who we enter in our contract with. So it's really important when we get our applications submitted that they are included and they are reviewing the information that goes onto the application forms, and they're the ones who sign the declaration on the last page and who we're entering into an agreement with. On that note, there's often confusion, particularly where now mixed use is becoming more prevalent here in Canberra. So you've got, you know, the commercial on the bottom, residential at the top, people using shared grease traps and the like. It can get a little confusing, but in the end, more often than not, grease traps are installed on common property, which means that it's the owner's corporation responsibility to make sure they set up the appropriate lease agreements and things to make sure those grease traps are managed properly. And we'd be looking for the owner's corporation or their delegate to be managing the connections to those grease traps. We endeavour to get back to people within 10 business days of receiving an application. And as you all know, you know, once we get them in and have an initial review, we usually enter into a conversation if we need to ask for additional information if it's not presented in the form. And, you know, Icon Water does reserve the right to refuse approval of applications for liquid trade waste. We need to make sure we protect our sewer network and keep it running efficiently. On that note there, you will see that I've popped on just an image of our application forms. So we had a new iteration of the application forms early this year. So January, we released a new form, and we have been getting some feedback on that, and we're aware that some changes are required. So we're going to be working through that in the coming month or two, and we'll probably go out for comment and get some actual feedback from how it's going. We've got some idea already, and I think we're going to talk to a few extra consultants and things this time around to iron out the last few little things, hopefully, to make it a more well-rounded form as best we can. You know, it's hard to make it fit every situation, but certainly open for review. Where to find information on our public website, we have a dedicated page for liquid trade waste, and on that page you can see here the snapshot here on the right. On the right-hand side, we have application forms, fact sheets, brochures, and all our policy and guideline information is right there, as well as contact information if you want to get in touch with the Trade Waste team directly. Our phone number, team phone number, and email address is on there as well. So some common queries. Multi-tenancy properties, as I said earlier, this one is a little bit of a minefield at times. We have tried to put on our opening pages of the application form some information to try and break that down as to who needs to sign what forms. As you can see here, hopefully you can see on the right, the snapshot I've put there, we talk about in the point 2, it's the multi-unit building with a separate unit titles. So if the pre-treatment device is within the footprint of that individually owned unit, then the property owner of that unit is responsible, obviously. If the grease trap or other treatment facilities within common property, then we would be looking for direction from the owners corporation to find out how they want that managed, who's going to manage those connections, because as you can appreciate, we're accepting the waste at the outlet, at the end point of that treatment process. So we want to make sure that our agreements are in full line sight of who's managing the connections to that pre-treatment and making sure that the cleaning and maintenance is getting done as required. So that sort of covers that off. In any case, in any agreement we have, approvals have to be updated every time a tenancy comes and goes or business activities change. So more often than not, particularly in these complex mixed use places, we find when we come and do a site inspection or an audit or a desktop review that things are just way out of date. Shop fit outs happen, they go ahead, and we don't see any paperwork to get those updated. It is improving as the awareness gets out there, and as we try to attend more events like this, and you know, educate the public as well and the business sector around what's required. And again, we are trying to improve our processes around applying for approvals. So the next line there goes to say if there's an existing valid approval for a property, you can submit a variation request. So that's sort of designed to try and make it a little bit more simpler. So if it is just a tenancy change or a business name change where it's moving from one cafe or restaurant to another restaurant or cafe, you know, the type of waste stream isn't dramatically changing usually. So, but we do like to know who's connected, what they're doing. Have they changed their fixtures dramatically? Is there going to be a higher load of oil and grease from that? So we like to keep a check on that and also make sure that the grease traps aren't being overloaded, so that, you know, while there might be multiple provisional points accessible in these buildings, we don't want it to get to the point where all of a sudden all those provisional points are in use, but in actual fact only, you know, 3 of them would have been valid before the grease traps overloaded. So it's really important that we have a line of sight as to what's going on the property, and hence why we devise these variation requests to try and make it a little bit more streamlined where possible when the existing approvals are up to date. So that was that. And the other one I was going to touch on was pumped waste. So we've been getting a few queries about this, and I'm aware that we don't currently have fields on our application form to deal with pumped waste. However, we do invite people to add attachments to their applications of whether it's about pumped waste or chemical safety data sheets and whatnot. So that would be good. I've just seen, is there something in the chat? Somebody's, oh, okay, sorry, I'll grab the questions at the end. But yes, we always invite people to add attachments to their application. And in our guidelines, we have, particularly for pump waste, we do have listed information that we would like to see at a minimum submitted with applications. So, and I've put those dot points there on the right-hand side of the slide. I won't read through all of them, but they are also within the guideline for pumped waste. But basically, the reason why we want to regulate pump waste is because obviously it can turn anaerobic, which can then cause corrosion issues and unwanted odours, as I'm sure you're all aware. So that's why it comes to trade waste for us to manage and just have an oversight as to what's going on in these buildings, particularly as more and more of these mixed-use residents and things come in. You know, they've got the basements and they're having to pump back up to the sewer main. So we just want to make sure that things are managed properly and that the right management flow rates and all the rest of it are included. So please do provide the information, and that's why we keep asking for it. But I think in the next iteration of forms, you know, we might put some prompts in there to improve the supply of that information going forward. The other thing with pump waste I want to touch on as well is that if it is a new development, we need to make sure that the design acceptance approval has come from Icon Water already for that pumped waste, just to make sure that the modelling has been done to allow the flow rates into the sewer main in that area have been calculated, and that the sewer main can accept those flow rates appropriately. So that should all be done and approved before it comes to trade waste for approval, so that we can make sure that that part of the work has been done, and that's done by a slightly different team. So, you know, doesn't mean to say we can't talk internally, but it's a quicker flow through process if you get that approval done first before you come through to the trade waste team. I'm not quite sure how long I have talked on for, but I was going to leave it there and open up for questions if that's okay. I can see there's a couple that have come through on the chat.
Yeah, so there's one from Nick, just asking if Icon is privately operated or owned by the government.
So we're private, well, I don't know what the exact terminology is, but our main stakeholders are the government. So our profits do go back to the ACT government, but we're not government operated, private corporation. Next one from Kate.
Is wondering if there's fees to building owners if they don't update Icon on their tenancy charges.
Yeah, so at the moment we don't have fees here in Canberra. Doesn't mean to say they won't come into the future. At the moment, if records aren't updated, the site is deemed non-compliant, which means that you're in breach of the legislation, basically. So every customer has to enter into a negotiated customer contract for trade waste. It doesn't get covered in the standard customer connection contracts. So if that's occurring, it would be a breach, and we'd be following up through the non-compliance escalation process at this point. Saying that though, some of our trade waste guidelines and policies are likely coming up for review over the next 12 to 18 months. So we'll see what develops in that space. But as I said, there's no fees at this point in time and hasn't been for quite some time.
Shannon, what are the requirements around home childcare centres that might prepare food for the children?
Home childcare centres.
Yeah.
Yeah, we try to take cases on merit where we can. Obviously, we need to stick to our guidelines, but it's really dependent on the size, how many kids are coming there, what sort of meals they're cooking. So, you know, if they're doing heavy cooking, that would be equivalent to, you know, a cafe over the period of a week. Then we'd be needing to look at some sort of grease arrestor, whether that would be your traditional grease trap or something else. It's tricky because we want to be fair to the business sector as well. So we are assessing based on risk and what activities they're actually doing.
Okay, no, that sounds very reasonable. So Tom Roberts has a question. Is a separate grease trap required in garbage enclosures where garbage enclosures are shared or not within close proximity to the grease trap for the food tenancy?
Yeah, so this one comes up a few times. I just wanted to make sure I understand the question. So we've had a couple of late that have come through where I suspect their building design have been done, and they were like, well, we haven't accommodated for the garbage enclosure to have to flow through the grease trap. Now, technically, I don't really find that acceptable given the requirements are published in our guidelines, so that should have been considered during the design phase of the building. We don't generally require them to go through a grease trap if there's not going to be a grease trap there for commercial tenancy already, obviously. The whole idea is the premise of it is that, you know, if the commercial entities are there, they're going to be taking their waste there, they're going to be rinsing it out, there's going to be greasy, oily residue going down the drains. So that's the whole obvious premise behind that. Saying that though, in existing installations and things like that, we do a sort of merit-based case assessment as to whether we would make that to be a requirement or not. We don't want to be also adding further hazard to the design of making something pump from a basement to a grease trap elsewhere and then back up to the main as well. So what we really encourage is that these things are thought through at the early design phase so that, you know, they're engineered properly from the beginning. That's the reason why we require it. And we would ask for that to be respected and considered during the design process. Does that answer the question?
Tom, how did that go for your question?
Great, thanks, Tom.
And then Kate's just got one just to understand whether or not a non-conforming arrangement will be fined.
Yeah, at the moment there's no capacity in the legislation to issue fines, and that's at the higher level of the legislation related to trade waste, although that doesn't mean to say other avenues wouldn't be explored. At the moment, you know, there's penalty points issued, so it's actually an offence to be non-compliant, depending on what the non-compliance is and what it would be deemed to be under the legislation. So there's a number of quite predetermined definitions there around causing an interference or being illegally connected, those sorts of things, and they all carry different penalty points, which obviously translates to fees. It can be quite expensive for either individuals or business and corporations as well, if they do breach and they are found in breach of the legislation. So while there's no small penalty fees as such that we would charge, it doesn't mean to say that, yeah, if it fit those categories and it escalated all the way through to full-blown serious network protection cases, that, you know, Icon Water would reserve its right to take it the whole way through.
Do Icon Water have an approved list of trade waste devices that might be more acceptable to them than others, as some other network utility operators do?
Yeah, we don't. We are considering that sort of thing, as I said, in sort of the next 12 to 18 months. We're possibly looking at a guideline review. That's not confirmed, but it's looking that way. So that we often get questions on that. As you can appreciate, that takes quite a lot of time and resource to manage. So we're just looking at different options of what we might do in that space. and whether we would go down that path or not, or whether we would have a set of just high level requirements that, again, we don't tend to get into the space of being the designers. You know, that's where we leave it to people like yourselves, the hydraulic consultants, to, you know, keep up with industry best practice and new technologies. And, you know, Icon Water is really keen to try and partner with the community to, you know, keep moving forward with these, with treatment options. At the end of the day, what we're interested in is being able to have a device that's installed to pre-treat the waste, so that's going to hit our sewer system at our acceptable limits, and not cause issues into the network, and for the safety of our personnel and the public, obviously. So yeah, that's kind of where it's at. Is, you know, I sort of feel like it's a tricky one, because I can see how it would be really useful for consultants and the public to just go, yep, they accept that, let's go on and get it done. But at the same time, you know, that would require us to have to keep upgrading, changing the list, to try and keep up with new solutions and potential options that could be put out there without sort of sniving, you know, improved ways of thinking about things, if that makes sense.
Totally. And what are the process requirements for discharging I-131 to the wastewater network?
Beg your pardon, sorry?
What are the requirements for discharging, say, I-131, like iodine 131, which they use in hospitals from time to time for thyroid cancer treatment?
I believe we had a query on that not so long ago. I'm not across the full detail because I was away on extended maternity leave at the time, so I'm not quite sure what was put in place on that particular one. Anything that is not listed in our trade waste acceptance guidelines, we are able to calculate site-specific requirements as the applications come in.
Sure. So it would be approach Icon and demonstrate the quantity and then have
yes.
this.
Yeah.
Okay. Tom Roberts has made a comment that there's an Australian standard for grease traps being prepared at the moment. I know Kate Jennings is actually sitting on that committee, so maybe Kate, if you're there, it would be nice to just get a little update.
Sure. Hi, how is everybody tonight? That committee's been going on for probably, I think, just over a year now, and COVID has kind of slowed all of the development down. But I think the intent is that we'll have a standard out within kind of the next 18 months or so. And part of that would be a performance test as well, to check that, you know, grease traps are doing what they should be doing in terms of you know, separating. So I think perhaps that might kind of solve that issue that you're having, and many other water authorities are having around the country, of trying to maintain an approved products listing. And instead it would be up to the manufacturers just to say that their products are compliant and have the tests there to prove that, and that would be kind of the tick of approval, because I think that's been on the water authorities in this time because of the lack of the standard you know, in the market. So perhaps that would kind of, you know, solve that.
Yeah, absolutely agreed. And I'm aware of that work going on, and have we get updates through WASA, so the Water Service Association of Australia, frequently. And yeah, I know Colin Hester who's working on that as well. So yeah, thanks for the update though, Kate, because I hadn't touched base on it for a little while, so that's good to know.
And Kate, out of interest, is that going to be sort of adopted through network utility operators legislation and what they operate under, or will that sort of fall under the Plumbing and Drainage Act, or sort of just a TBC?
I'm not sure, to be honest with you, but I can find out and come back to you on that.
Yeah, that would be interesting. Thanks, Kate.
Okay.
Any more questions out there tonight? No? Well, great. Thank you very much, Shannon.
Thank you very much. Appreciate the time. I'll just stop sharing. I don't mean to be rude, but I do have a small toddler here at home, so I might rush off and get her organised for bedtime, if that's okay.
Thank you very much for your time.
I really appreciate you inviting myself on behalf of Icon Water, and we hopefully look forward to continuing communication.
Absolutely. See you next time.
Thank you.
Yeah. Sorry, I'll just get my screen sharing happening again. Okay, so next up is Pat and Nick from Grundfos. They're going to be talking about smart pumps. So these are variable speed driven circulating pumps, and some of the innovative ways that one can go about solving some of the day-to-day problems with balancing in domestic hot water services. So welcome Patrick and Nicholas.
Hi everyone, thanks for having us.
Hi guys.
So
Just share screen.
share screen, just 1 second. Get there. Are we?
Just click on that one.
Can you see our screen?
Not yet.
No, okay, so what happened here? Let's see.
Give us a look.
Just 1 second.
Underscore. Yeah, so go on onto your screen then.
Lost. Locked. Just hold on a second. Okay, yeah.
Just one of them. Sorry, Tom.
Okay.
Yeah, there.
So in conjunction with Patrick and Nick's pumping systems, there's some really good balancing valves on the market, which are constant flow, variable pressure. So if the pressure does change in the system, or the pressure is a little bit difficult to calculate, these are great valves for solving that problem. All valves sell them. They've just currently become watermarked. So one of the few balancing valves on the market which are actually watermarked, and they'll do a large flow range. So definitely something to check out on the All website.
Oh, I lost them. Hello?
There. Keep pushing it down. There. Okay.
Hello?
Looking good, guys.
Okay, can you hear us and can you see the screen?
Yep, can do both.
Okay, good. Sorry for that. Okay, so yeah, thanks for the invitation, Nicholas, and have Patrick with me here. We're both account managers at Grundfos, New South Wales.
Hi guys. I'm Patrick and I'm mainly based in Sydney. I have a section of the business that looks after the CBS market.
Yeah, so we both combined, we have more than 20 years experience in the industry. And today we wanted to share a bit of experience with regarding the intelligent circulators. So as you explained before, so this kind of pumps have been used in different countries for a while, but not in Australia, not so popular yet, mostly because of the pricing limitations. So what we want to present today is why we should be moving to intelligent circulators. So this is a typical circulator that is currently used in Australia. This is, for example, a UPS. These pumps were released in the 70s. So it means that we are currently using a quite old technology. Since then, Grundfos became one of the major players in this market. We're producing about 60,000 units per day nowadays. So a typical circulator will be installed in a system to be run at fixed speed 24/7, and basically they don't change this performance depending on what is happening in the system. So that's why we might call them dumb pumps, because they run uncontrolled. They don't have energy index ratings. So that's the main reason why they are not being used in Europe nowadays, because they are not approved, and basically because of the low efficiency. So this is an intelligent pump. We want to present the key features that an intelligent pump should have to be qualified as an intelligent pump. So these pumps are what we say a problem-solving machine. And the main things they have is they have built-in sensors that we can use to monitor data, and that data could be used to optimize performance. They have thresholds that can be used to protect the pump through alarms and warnings, and can be also customized based on what you require for the specific application. They have built-in VSD. So with the VSD, we can adjust the pump performance to the changes in the system. They have remote communication and control, which could be translated into savings in transportation, because a service operator can monitor the pump remotely using a BMS system, and have all the information ready to decide what to do beforehand. They might have predefined control algorithms, for example, a constant pressure, or a constant differential pressure, or a constant differential temperature. So all these control modes are already predefined in the pump. They already have a setup wizard, and that would make the commissioning quite easy, just a few steps, and the pump will be ready to run. So that's also saving money in labor and commissioning costs. Finally, these pumps will be able to reduce system components. For example, in closed loops, where you have mixing loops and balancing valves, you can eliminate completely the balancing valve, just installing an additional temperature sensor on the return line. And with that, you can monitor the delta T, the differential temperature in between the suction and discharge, let's say, the supply and the return line. And finally, fault prediction. So these pumps will be able to predict possible failures with the data that they get through the sensors. Nowadays, they have codes for failure or alarm, so they will tell you what to do in case of a specific threshold is exceeded. So yeah, for example, if temperature is very high, so it will say, okay, temperature is very high, you need to do something about that, otherwise the pump will fail. So these kind of things can be also customized based on the system. So yeah, these intelligent pumps could be overwhelming with too much information. For example, typical data points that you will be able to monitor power or load percentage, or how the pump is controlled, or what is the set point, or what is the flow. And having too much information could be difficult to manage. It's very important to get exactly the right information that you need. But by this, you need to also define what inputs and outputs you want to use, and what information you want to gather from the system. And then you can use a bus, a field bus to communicate that information, for example, using a Profibus or a BACnet. So all these features are already integrated in a smart pump. So just to show a brief example, comparing a typical UPS against a Magna 3, which is the intelligent pump. So if you see to the right of the screen, we have some initial costs. So the pump price of a UPS could be half of the price of the Magna 3. And when you add all the accessories that you need to make it smart, so the overall cost of the UPS, the initial cost, would be a bit higher than the smart pump, let's say about 10%. But if you wanted to compare just the typical pump running at fixed speed against the intelligent pump, for example, in a period of 6,800 hours per year, with 14 cents of dollar per kilowatt hour. So you will have about 2 years of return on investment, mainly because of the energy savings. And after that, let's say 10 years after, you will be saving about $4,000 in. So basically you have already paid the investment twice. So these pumps are really money makers, with savings of up to 75%. So I think this helps us to answer the question, why would you use an intelligent circulator? So the main reason is energy savings and also extended control features. So here, for example, we're comparing a typical circulator against the Magna 3 based on the energy efficiency index. And as you can see here, the Magna 3 is a pump that has an energy efficiency index of 0.18, which is already below the benchmark. And the typical circulator is not even rated because it's not currently used in Europe, for example. So just to give a brief explanation of the energy efficiency index for people that are not familiar with that. So the European Commission, they started to work on this legislation in 2009. They started with motors and circulators, and they set a goal to reduce the energy efficiency index below 0.27 by 2013 and by 0.23 by 2015. And currently the benchmark is 0.20. So we can say that an intelligent pump like the Magna 3 is currently below the benchmark, which is, let's say, how can we say here, like the tomorrow's pumps are already available. So just to put that in numbers for Australia, if you think about the market size, the circulator market size for Australia is about 60,000 units per year. So if you remember the beginning of the presentation, that's about the production of ground force in 1 day. So in 1 day, ground force will be able to supply the whole market for 1 year. And this, it's equivalent to 47 millions of kilowatts per hour per year and 42,000 tons of CO2 per year. So if we were able to replace all these, let's say, dumb circulators for intelligent circulators with a potential saving of 75%, so we will be saving about 35 million kilowatts hour per year and 32,000 tons of CO2 per year. So that's equivalent to Bathurst or Orange in terms of, I mean, in New South Wales, in terms of energy use or CO2 emissions. So it means that every year we could be removing the energies of something similar to a town with these intelligent pumps. So up to this point, we spoke about individual pumps, but smart pumps will allow us to turn them into systems very easily. And the main reason is because of this expanded communication features that they have. So if you see here on top of the slide, so we have the Hydro Multi-E. It's an intelligent system with 2 CREs, so they are very common multi-stage pumps with integrated VSDs and control. So these pumps can be configured for example, in a booster system with up to 4 pumps working in cascade without the need of an external controller. So everything's done directly on the controller in the motor. And if you see below, we have for example, the dual Magna 3, which is 2 Magna 3s talking to each other, could be wireless or wired to operate as jury standby or as a backup operation. So you can see the benefits here is that you have reduced maintenance downtime, mostly because of this multi-master function. That means that if one pump fails, so you have another pump that will take over. And then all these pumps are, as we mentioned before, so they are already suitable for conditioning monitoring due to all these inputs and outputs and the field bus communication which is available in the intelligence of the pump. Due to the high efficiency, so we can reduce motor sizes. So that's the main benefit in terms of energy efficiency. As we mentioned before, the commission is faster and easier. And we also mentioned that we don't need an additional controller. So all these PLC features are already integrated in the VSD. So for example, we might have the customized thresholds that we can program to limit variables in the system. So for example, in a booster system, you can say if the pressure is very low, so stop the pump because probably it's running out of the curve.
Or a pipe has burst or that kind of thing, yeah.
Yeah, you can also set, for example, low pressure could be a pipe burst, or high power could indicate that the pump is running very far to the right, maybe cavitation. All these things can be monitored with intelligent pumps with no need to install any additional sensors or controllers. Yeah, and finally, we could be saving in wiring as well, because pumps can talk to each other without the use of wires, and also the sensors are integrated directly, so shorter wires, and also the VSDs are in the same pump, so less wires. So it's a lot of savings there. So I think that covers what we wanted to present today. As a conclusion, intelligent pumps are more efficient, 75% more. They have a communication, integrated communication, VSD, that can help them to adapt to changes in the system. And they have the possibility to integrate with other pumps to turn them into a system. So that's what we wanted to present today. If you have any questions that you want, we're happy to address.
Thanks, guys. That was really good. One thing maybe just to touch on would be setting the Magna 3s. You've got the option for head and or flow, haven't you?
That's right. Yeah, you can choose which operation you want it to operate in. So you go in through your settings and you set either constant temperature or constant pressure.
Yeah, so here's very important to mention that the pump has integrated temperature and pressure control sensors. Sorry. So we could control them directly with temperature or pressure, but they can use the pressure sensor also to estimate flow based on the information that we can provide from the system. So yeah, they could estimate flow, but that would be an indirect reading.
Yeah, but if anything, that would be the handiest thing on a circulating system because flow is quite easy to calculate.
Yeah, and I think it's as we mentioned before, I think it's very important to know the application, because that will tell us what is the best control mode for the pump. So for example, it's important to know what is the head loss through the system. So it's very high, so probably proportional pressure could be a better control mode. But if you have more like very important to keep a constant delta temperature So maybe the constant differential temperature will be a better control mode. So for that, the only thing that you need to add is an additional temperature sensor in the return line. So it's very flexible for defining a control mode.
Cool, cool. What sort of questions are out there at the moment? Highlight another one then maybe. So single critical point componentry and things like that, I presume that having the controller attached to the actual pump itself provides a lot better redundancy than pumps of yesteryear.
So, sorry, in terms of having the display there, is it the control side of it, or?
Having the pump, the fact that if a single control panel goes down and it was once controlling 3 pumps, you've lost 3 pumps, but...
That's right, yeah. With the 2 units, they can both act as a master pump.
Yeah.
So if one goes down, or even a sensor, there's full reliability on the second unit to run the system.
Yeah, I think it's very important what you are discussing, because if you see, for example, say this hydro multi that we have here on the slide, so it has full redundancy on different components. So we have 2 VSDs. So if one VSD fails, we have the other one. We have 2 controls. So that's what we call the multi-master. If one of the main pump or the master pump fails, so the second one will take over. We have redundant sensors, 2 sensors in the inlet, 2 sensors in the outlet. We have 2 pumps, so if one fails, we have the other one, you know, in the hydraulics. So it's full redundancy.
They're pretty bulletproof.
Yeah, very reliable.
Yeah.
Same with the small dual system, the hot water circulation system. Same thing. If you have one pump failing, so we have full redundancy with the other system. And they could be even independent in terms of control. They have integrated control, each of them. So yeah.
And if you got a damaged motherboard or something electronic in it, those parts generally come as spare parts as well.
Yeah, very, very important to mention that, because in the past, there were some issues with the failure in controllers. I mean, in terms of the smart pumps, and we had to replace the whole unit. But nowadays we can sell just the control part as a spare part. So it's also easier to service now.
Yeah.
And I think jumping back to the variable speed Magna, one of the other good features of the ability to set pressure and in turn flow means that you won't have any unintended consequences with velocity creep, because if a normal fixed speed circulator duty point of the system is below the curve, it'll actually increase the flow and therefore increase the velocity. So risk of non-conformance with the DTS provisions in relation to velocity. So that's quite a great feature on those pumps.
Yeah, and for example, on the Magna 3, I mean, we didn't go into that much detail, but there is one control mode that is called auto adapt. And we can set the maximum flow. It's called the flow limit. So you can say, okay, I don't want the pump to exceed this flow. Just set it on the screen, and the pump will make sure that the flow is never exceeded.
And that will operate with the auto adapt feature as well, which takes in proportional pressure.
So it will adapt to whatever changes are in the system.
And that's where most of the savings in energy comes from. It's not just the actual motor or hydraulic improvements, it's the integration of the pump into the system, so it can take information back and see what's going on and react.
If you want, we prepared just a few questions, because I know that from our previous meeting, we had very interesting questions. So if you want, we can just go through them very quickly.
Oh, no troubles.
So one of them was, what is the minimum inlet pressure in an intelligent circulator? So because in the typical circulators, the minimum inlet is 4 meters. So these pumps, they can reduce the minimum inlet pressure up to 1 meter. And you know, for for example, in a magnet 325-60N with water up to 75 degrees Celsius. So as you can see here, 0.1 bar, so 1 meter inlet pressure. So, but anyway, if you want to have more detail about that, you have the copy of this chart and even more information. So we recommend to refer to the technical documentation for each pump for more detail. Another question was, what happens in an intelligent circulator when it runs dry? So that was a good question, because we thought that the dry running protection was still enabled there, but we were talking to the product specialist, and they say that currently this feature has been removed temporarily, because maybe sometimes it will trigger without requirements that we have here. So it's better not to have it, and just have a different way to monitor dry running, for example, as we say, like using power or pressure.
And just with these pumps as well, they're a bit like your iPhone, and that you can get software upgrades, and the software upgrades will bring up new features that are available, even though the feature was made after the actual first delivery of the unit.
Mm-hmm. And finally, they ask, what is the status of the energy legislation in Australia for circulators? So that's very important to address, because it's the main topic of this presentation. So we are aware that the Department of Energy and Environment has been working on an investigation on hot water systems in Australia, and they want to include this in the energy rating legislation. So far, no conclusions. So we don't have a legislation yet for Australia, which it's just a bit disappointing, because as we mentioned before, so other countries are much more ahead in terms of legislation. Like, I mean, in general, the European Union, they have been talking about this for 10 years. So we could say that we are 10 years behind.
We've got another 5 to 8 normally.
Yeah. Yeah, so I think, as we said, I think it's important that we start to talk about this, because eventually the market will be moving in this direction. And I think if we give these first steps first than anyone else. So yeah, we could be showing the way, leading the way for other companies to start using more intelligent pumps.
Brilliant. Well, I might just see if anybody from the floor would like to ask any questions, and if not, we'll welcome Colin aboard. Great.
So anyway, here are our contact details. So you can send us an email or call us directly if you want to discuss any particular issue or any project that you might have.
And you guys would help out with pump selections and the like as well.
That's right, yeah.
Brilliant. Thanks, Nicholas. Thanks, Patrick.
All right, guys.
Very informative.
Thank you, Tom.
Thank you.
Thank you.
Thank you for having us again.
Pleasure. Okay. Thanks once again, guys. Our next presentation is on air valves by Colin from BERMAD. So welcome, Colin. It's been a while since we've seen each other.
Thank you. Yes, it is, Tom. Thank you. Appreciate that. Yeah.
Thanks for coming along and talking about air valves today. I think this is quite an important topic, because they're a little bit unknown in the industry and can be sort of reasonably unfamiliar. And as you know, there's air valves and there's air valves. And then also the DTS provisions of ASNZ 3500.4 have definitely changed of recent, mandating air valves at high points in circulatory heated water systems. So that's a very important thing to remember, so that as engineers and designers, we don't get caught up by overlooking that requirement. So that means that any PCA 2019 projects would would pick up that that DTS provision there. So I'll hand over to you, Colin.
Okay, thanks very much, Tom. Appreciate that. So hopefully everybody can see my screen okay. You can see the PowerPoint presentation here?
Yeah, looks good.
Right. So, so thank you for the opportunity, Tom, and everybody for giving us this chance to discuss some of the air valves. So for you who don't know me, Colin Kirkland's my name. I represent BERMAD here in Melbourne tonight. So haven't ventured far out from the house for the last 8 weeks. So this is exciting for me to do some Zoom meetings. So thanks for the opportunity. So what I really want to discuss a little bit here is a lot of the time when I talk about where air valves are used in buildings and how they work, I always tend to presume that people actually know what an air valve is. So I want to talk a little bit about and show you a little bit of animation so that people actually understand what the terminology and what the products are. I want to talk a little bit about how air actually gets into the buildings, how it gets into these networks, and some of the effects that it has. So the effects that it has on the efficiency of the circulating system or the water transfer system. And we'll talk about some basic hydraulics of actually how air physically moves in a pipeline and how to release it. And I'll show you a couple of products which are suitable for those types of applications as well. So let's talk a little bit about the most common type of valve which is used in pipelines and in buildings, and it's called a combination air valve. And what do we mean by a combination valve? Well, what a combination valve means, it's got two primary functions. The first primary function is that when we come to fill any network, we want the float to be open. We want to allow air to release. And then in the presence of water, when it finally comes up into the actual valve itself, we want it to close. Now, we can have some what we call anti-shock mechanisms in there too as well, but we want to ensure that the valve closes and doesn't discharge any water, because in a building that's an issue. But more importantly than that, we want an automatic function. This is what we're looking at now. This is the automatic release of air under pressure. And of course, if we drain a system, which is pretty unusual in a building, but if we do that, we want the floats to drop to allow air to come back in. So a combination valve means that we're basically allowing air out, we're allowing entrapped air out under pressure, and we're allowing air to come back into the valve itself. Here we're looking at the CSA Fox air valve and the building version of it here. So this is shown in a metallic version. So this is a valve suitable up to 70 degrees C, which is made of ductile iron. It's a little heavy, it incorporates strainers to avoid contamination, and it's designed such that we don't want the air valve to also generate potential water hammer through filling as well. So as well as a combination valve, you can have what we call an automatic valve. Now, an automatic valve is sometimes referred to as a single orifice air valve. Its primary function is to release entrapped air when the system is under pressure. So if we had a hot water circulating system, and this is one of our hot water air valves here, what we want this valve to do automatically without opening and closing ball valves is we want this to release entrapped air. So what we have inside the valve is a float, but with a very small orifice. So the orifice might be somewhere between 1 to 2 millimeters roughly in size. Here we can see the animation of how that automatic function works. So as entrapped air builds up inside the valve, the float drops and purges the air out through the valve itself. Now, what is important when you have a function like this, I'll just repeat that one more time, is that we sometimes get a small amount of moisture discharge at the same time. So it's important to have a threaded outlet on the top of the valve that we can run that to a tundish that might take away any moisture, because we certainly don't want damp spots in a wall or in a building anywhere. We want to try and keep that away from anything that's present. So that's what we refer to as an automatic air valve. And typically the valve size is a maximum of about 25 mil or 1 inch BSP. So today in the market, there's many non-metallic air valves. Today, we are the only company in Australia to be Australian standard certified and was appraised for non-metallic air valves being used in water supply, but it's rarely used in buildings. Not for any other reason in performance. It's very, very good in low pressure sealing. It can still handle the majority of cold water temperature applications, but really shouldn't be used for anything other than cold water. We know the effects of temperature and cyclic on and off with pumps and everything else, and temperature degradation through valves over time. And we want to, if we're putting an air valve in a building, we want it to be a long-term proposition that's going to be reliable. But in some applications, for water, cold water, it may be worth considering something like this. Usually this is a combination air valve here. So even although it looks like it's a single function, when we look at the cutaway inside the valve, this again, two primary functions. It's a combination air valve. So it's going to remain open until water comes up into the valve. It's going to have a peel seal that automatically releases the air through a rolling membrane. And that's the automatic function. And finally, as I was saying before, if the pipe goes into vacuum, if there's a partial drainage, we want to allow that pipe to drain by allowing the float to drop and allowing atmospheric pressure to come back in. So here we're going to see the function where the air comes back in. So the float drops and then comes the air. So typically the valves are available either metallic or non-metallic for most of the applications. So let's talk a little bit about some basic hydraulics. So how does actually air get into a building to start with? A lot of the time when we take a new premises and the air is purged and everything else, people just tend to say, look, the air's gone. There's no need to put air valves in because we've manually released it. It's all good. But the facts of the matter are, is that whether it's a pipeline or building or an irrigation system, if you reduce the pressure in a network, air comes out of solution. So especially if we're talking in the major capitals, in the Melbourne, Sydney, Brisbane's, if we have a 30, 40-story building and we've got a series of pressure reducing stations that we see here, we've got, in some cases 2-to-1, 3-to-1, even up to 4-to-1 ratios sometimes through a pressure reducing station, air comes out of solution. So if we're vertically running down, so in this case, we're actually running up the building here, but if we were running down the building and air's coming out of solution, that air is going to be entrapped at the top of that network. And it's not good to have air entrapped in the building. So pressure reducing stations look in a variety of different locations. Here we can see them running from west to east and running up the building. Here we can see the same sort of system here. And these are larger design flows for the sort of trunk mains through the building itself. But so reducing pressure is one of the main applications where that air comes out, and we want to release it. But what about hot water circulating systems? Well, one of the things we know is that there's a correlation between the percentage of air that remains in water and temperature. So as you boil the kettle, as the temperature increases, more air comes out of solution. So we tend to see, we see this every day in irrigation in hot houses where they're circulating hot water, in nurseries and stuff like that, where they have real issues of entrapped air in hot water systems that really reduce the efficiency of the networks. And we want to release that air because we want the pumps to work at the best efficiency point. We want the system to be efficient, and we don't want entrapped air in a hot water system. Why? Because the mixture of chlorine, hot temperatures, and air is a cocktail that's going to deteriorate the life of the pipes and fittings in the network. And we know this is a really big problem today. So this is why we want to release the trapped air, especially in hot water systems. But, in most of these networks, we're usually starting off in a basement where we've got pumps. And, we're talking about pumps that are running from through 2-pole motor pumps at 2,900 RPM, where we're highly agitating the water originally as we're coming out of pumps. And when that happens, small amounts of air comes out of solution. As we rise up the building and the pressure drops, more air comes out of solution again, and it gets entrapped at some of those higher points. So we want to get rid of that for the whole system to work efficiently. We'll talk about water hammer and some of the other efficiency things in a second. But one of the other things that can happen, especially in a building, if you've got exposed pipe work on rooftops, etc., is that, in most places around Australia, we're talking about some serious differences in temperature from morning to night. And as we change that temperature in the pipe, we get air coming out of solution. So air release, especially at the very tops of the buildings, are really probably one of the most critical points where we need to release this in the air to make sure we maximize it. And one of the things is, of course, is that the size of an air pocket that actually builds up inside any sort of pipe network can be compressed if the water pressure is greater. And the greater the water pressure, the more we're going to compress that air into the water itself. So when we're talking about gravity systems coming off the top of tanks and flowing downwards at very low pressures, we want to make sure that that air is being able to be released effectively. Now, the issue with a lot of air release valves is that they have a minimum sealing pressure to ensure that they're actually going to seal. Now, here, if we can see a couple of air vents sitting along the top of this building as we're running down into the network. Now, if we didn't have sufficient water pressure here and the air valve started leaking, the easy thing to do is just to turn the air valve off. So you've got to be very aware of the minimum sealing pressure of different valves to make sure that where you're locating these valves, it has a sufficient pressure to make sure that it functions correctly within its network. Now, some air valves need anywhere between 5 to even 10 meters of water pressure before they'll seal. A lot of the new valves in the market today will seal at pressures close to atmospheric. There's a lot of new technology and designs have gone into air valves to ensure that they actually still function and they still seal. And importantly, they don't actually blow shut with air when they're trying to release air. So you need to be careful when you're designing valves to make sure they've got sufficient pressure for them to actually operate. Now, when we talk about in building networks, and we're talking about smaller localized pressure reducing stations, where we might be talking from 20 or 25 millimeter in size, and they're running into maybe 2 or 3 apartments. Usually you don't tend to find a lot of air release valves into apartments and buildings because usually you've got sufficient water velocities and everything else to move and to purge that air through the network into the apartment, or by just opening showers or faucets and just getting the air out itself. But really importantly, if you're ever moving water vertically downwards, that's the biggest challenge, to actually try to get air to move downwards. So in localized stations like this, where we can see an air valve at the top here, when we're flowing downwards, we're using a small air vent to ensure that that releases effectively too as well. So what is one of the biggest issues that we've got, and how do we get air into buildings? It's usually in new installations. So we know this because at Bermad we sell a lot of air release valves and a lot of pressure regulating control valves, as in pressure reducing valves, tank fill valves, etc. And a lot of the time when we're trying to commission pressure reducing valves, the thing that we hear all the time is the valves are bouncing. Colin, they're hunting up and down. We need to get someone out here, technician, do something to the valve's not operating. We need to ensure that we get this valve stable. And 99.9% of the time, it's nothing to do with the valve, but it's the fact that we've got dead end pockets of compressed air. They're acting like small shock absorbers. So one of the things that we suggest, of course, is that when we have a new network of different floors and buildings, is we say to the plumbers, look, get into the apartments, get in there, open up the taps, induce some higher velocities. Let's get that air moving so we can get it away from these dead ends, So it's the same whether we're talking in a building or we're talking in a transfer pipeline with Yarra Valley Water or somewhere else. If we have dead end pockets that we can't release and trapped air, it's a problem, and if it's entrapped at a higher point where there's no way of getting air released and there's not sufficient velocities to move it, those pockets just simply compress. And it's really highlighted when we have pressures lower than about 2 bar, 200 kPa and around that and lower is when the air bubbles are at their largest, and where this really becomes a real problem in a building network. So in brand new buildings, it's imperative that we get really good flushing of all the networks so we can actually get rid of that to start with. And that's a good starting point. So what are some of the issues? So if we have a bit of air in the pipe, who really cares? Well, I guess the whole point is that if we have entrapped air pockets at those higher points, and if we were designing a pipeline that we were running from Melbourne to Geelong, and we've got a couple of induced high points, we can put air valves along that pipeline and release it. But in a building, potentially we could have hundreds of high spots in a building here where we have to release that air effectively or find a way of getting rid of it. Because if we have entrapped air in a pipeline and it's at relatively low pressures, with potential to really reduce the flow capacity of that pipe. So, you know, a 40 millimeter pipe with an air pocket could be producing a 32 or 20 millimeter diameter pipe performance, you know, so we want to get rid of it. Now, the other thing, of course, is if we have air in a pipe, it's compressible. When we have washing machines, dishwashers, switch on and off, and we have potential air pockets that can compress when we have a rapid change in flow, that generates spikes, it generates fatigue in the pipe, and we don't want water hammer. We have potential for internal corrosion in metallic pipework and also in non-metallic pipework with air issues, and we know this is a very big issue in larger networks and hospitals and buildings today, so we don't want that for in any way. You know, when we've got flow meters and we've got small mag flow meters, we don't want circulating air in mechanical or circulating mag flow meters because it's going to give inefficiencies in their readings. And of course, you know, if it's going through, this air is traveling through regulating valves, we can get valves bouncing. If we've got it coming into pump suctions and circulating pumps, you know, we can create, you know, inefficiencies in the pump performance because we've got these entrapped air pockets coming along in the circulating pumps. So we want to release it to maximize the performance. Any designer of a pipeline network or a building, the best situation you can have at any time really is to keep the system full of water because it's non-compressible. So let's talk a little bit about some of the issues that we see in some of the buildings. Is that one of the things as an engineer when we're being conservative and we're trying to design things is that there's a whole series of criteria that determine what size pipe we use for different operating conditions. Now, the facts of the matter are, if you take the diameter of the pipe in meters and square root that value and multiply by 2, it gives you the water velocity in meters per second to move air horizontally. So I'll just repeat that. If we have a horizontal pipe, and we've got an air pocket stuck in that pipe, do we assume that if the water is flowing left to right across this pipe here, that it will always move the air horizontally? It depends on the velocity and depends on the pipe diameter. So that's what I'm showing you here. A 200 mil pipe needs about 0.9 meters per second to move air horizontally, 150 and 180 mil, etc. We don't tend to see a lot of air valves used in very small diameter pipes like 20 or half-inch pipes because usually there's sufficient velocity to move it. But the issues are if you oversize the pipe and we don't have sufficient water velocity to move that air pocket, it stays there. Now, people know in Yarra Valley Waters and Sydney Waters and all these water companies, if there's a break in the pipe somewhere and they need to release the air, they run along and put hydrants in along the pipelines, and they basically keep putting hydrants on until they induce sufficient velocity to move the air. In a building, that's a real problem because in many cases, if you look at what your peak flow performance in water velocity is in some cases, you could be as low as 0.2, even 0.3 of a meter per second. And if you've got that situation and you aren't moving the air, it stays there and creates the issues that you see in these buildings today. Now, of course, that's a horizontal pipeline. What if we have a declining pipeline? Well, look, when we design major pipelines, there's many formulas, and here's 4 different particular ones. We call it a critical velocity calculation. So it's basically saying, look, if I have a 5-degree fall in a 200 millimeter pipeline, am I going to have at 80 cubic meters an hour sufficient water velocity to move that air down? I don't want to put air valves everywhere. So there's many calculations and everything else that you can use to really determine if you actually need to have an air valve at that point itself. And we refer to this as the critical velocity calculation. So I'm not going to go into this in a great deal at the moment, but I'll talk a little bit more about it now too as well. Water hammer, it's a big issue. You know, the thing is that we know the effects in buildings. You know, you can have $1 million apartments and they hear the valves bouncing and they hear the pipes bouncing, and it's because, what is it because? Well, is it because the pipe's not braced? Is it because we've got pumps starting and stopping? Is it because we haven't got sufficient tanks to minimize when we've got, this is tank fill valves filling into tanks. Now, if we didn't have these separation chambers that took away the bouncing effect by float valves, you know, we could have major issues. And there's many things that cause water hammer in a building. If you've got air in the building, it accentuates that, you know, so starting and stopping of pumps, closing of valves, anything with entrapped air in it is going to cause some issue. And because we've constantly got flow changing all the time, because of toilets, because of showers, because of all sorts of aspects happening in buildings, anything that has a rapid change in flow is going to potentially generate some sort of hammer. So by the key thing is that by keeping air out, it's one potential less thing that's going to accentuate that a water hammer situation. So we know this through irrigation, we know this through mining, transfer pipelines and slurries, water, irrigation, sewage, all of that situation. It doesn't change whether it's a building or one of those applications. Air basically accentuates water hammer. So what are some of the ways that we can do this and do it effectively? Look, there are a lot of range of air release valves in the market that can do it. This is one of the products we have from CSA. The first thing about this particular valve, it's metallic. So it's ductile iron. It can seal as low as 1 meter of water pressure. It incorporates, well, it's PN 16 and 25 rated, but in a building that's quite unusual. You're usually working at the low end of pressures because the air valves are at the high spots. This particular valve comes 25 mil BSP threaded. It has a test drain valve in it that enables you to isolate the valve and drain the pressure out and do some regular maintenance on it, which is part of the Australian standard. The valve is approved for drinking water. So it has 4020 approval in Australia. It has AS, so there is a standard for drinking water air valves. It's called AS 4956. These valves are approved to that. There also was a certified for drinking water, but it was really interesting, Tom, and I'd love to ask a question of you at the end of this when you said that apparently up to 12 months ago, air vents were not required by Watermark, but from what I understand now, you're saying you are. So I'd like to bring that up at the end because we at BERMAD like to make sure our valves are approved for everything. Right now, we do not have Watermark for this, but we have all of the drinking water codes that are available in Australia today. We're one of 2 organizations in Australia to be approved for drinking water. So the issue is that you want something that's going to be safe. So why do we have a strainer on the bottom? Well, the main thing for the strainer on the bottom is to ensure that when we're filling the pipe, we don't want any construction, bits of Teflon, gal flakes, or anything coming through the pipe that is going to potentially block into this valve. We don't want that situation at all, because if it blocks, it's going to leak and it's going to create an issue. So we suggest that all valves have a threaded outlet that you can run to a tundish. So if there is any moisture discharge, it can safely get to there without affecting plasterboard or water running down in walls, etc. too as well. We also want the valve to also have what we call an anti-slam mechanism in it. This is an anti-water hammer device that says, no matter how fast a plumber comes and partially drains a bit of pipe to do a bit of maintenance and recharges it, we do not want the air to release out of this valve at a fast rate. Why? If it does, when it finally charges and generates a very large change in flow, it's going to generate water hammer. And that's what this anti-slam mechanism does, allows large amounts of air in, but controls air discharge. This is what the AS stands for, anti-slam. So this is a very safe, it's certainly by no means the imagination the most cheapest valve in the market, but it's a long-term, very safe valve designed for cold or hot water up to 75 degrees Celsius in hot water circulating systems too as well. And this is what we call the Fox HR. So this is the anti-slam mechanism I was referring to here as well. So typically, the thing that is important and the thing you do need to be aware of when you look at this valve is that it's not a small valve. When you look at the height of it, you know, potentially, I haven't got the exact specs in front of me, but it's something like about 250 millimeter in height, roughly. So in buildings, there's not a lot of room to put them. Now you have to effectively release air off the top of any pipe, you have to come off the top of the pipe. You can't come off the side or at a 45-degree angle and then put a vertical and have it coming up, because the entrained air is going to be at the top of the pipe. So sometimes this is an ideal installation where we're seeing looking at it on top. Sometimes it's not practical to put it there because There could be, you know, at the top of the roof, there could be additional pipes above it. It just might not be practical. So sometimes you can put a 90 bend on the top here, offset it to the side and then bring it up. So that's always possible, but it is important that this valve and any air release valve is usually designed to be within 5 degrees of vertical. So we don't want it on the 45. We don't want it, you know, on a slight incline because we just want to miss some of the building. We'll just try it that way. It should always be within 5 degrees of vertical. And I can confidently say that for nearly most manufacturers. That's good design practices and is part of the Australian standard generally. So this is just showing typically how to install it here too as well. We also have just a more compact version here designed specifically and only for hot water up to and exceeding 100 degrees. This is what we call the Ventolo. The Ventolo has the integral strainer again, has the threaded outlet, has the automatic function designed to release some small entrapped air. And we see a lot of these used because they're a little bit cheaper than the other valve on hot water systems. We see them on you know, return lines before they come back into the circulating pumps. So it's a ductile iron product which is electronickel plated with 316 stainless internals and Viton seals, designed for very high temperature water. Now, I don't believe most buildings will run more than 75, 80, I think that is. This valve can take a lot more than that, you know, but it's a more compact unit. It's called the Ventolo ST, and it's designed for systems. But these are long-term, very robust systems that are designed for buildings for long-term use and fully maintainable. So you can maintain every valve by undoing the unit, standard O-ring seals, replaceable seals in the mechanism. So this is something that a standard plumber can maintain quite easily without any real issue. And of course, it has this threaded outlet, which should go to a ton dish as well. Now, what we do on our website, bermad.com.au today, we put all of the operation manuals. We try to really put as much information on our website as possible because it's our catalog. So you basically find data sheets, airflows, you'll find operation manuals, you'll see animations, you'll see 2D and 3D step files. You'll see Revit files where applicable, where you can incorporate into the Revit system. But there's engineering data, approval, certificates, articles, case studies, and there's a lot of information you'll find on our website. And at all times too as well, we have the ability with all of our contact details we're a national organization based in Melbourne as our head office, where we do most of our assembly work and dispatches from, but we're based in Griffith, New South Wales, Sydney, Brisbane, Adelaide, Perth, and we have distributors Australia-wide too as well. And if all else fails, we have what we call a live field support system from our website, which basically says anybody with a smartphone, Android or Apple, can access the tablet, and it goes straight to one of our sales engineers that can look in a large screen exactly what you're doing and give field advice, whether it be you as a designer in an office or in a building for a plumber or wherever, you know. So it gives us the ability in this big country to give field support. So hopefully you found that useful. I rushed through this a little bit. I know I had limited time, and I'm sorry if I've gone over a little, but I was just trying to give you an overview of some of those issues that are in buildings. It's a very complex issue today, and it's becoming quite a concern in most cases. So are there any questions at all?
Not in the chat so far.
Good, yeah. Tom, do you mind if I ask a question of you, if you don't mind? You did mention that the DTS 0.4 you were talking about.
Yeah,
in buildings.
Standard for heated water services now calls for air relief valves or air valves to be installed in drinking water networks.
Yep, gotcha.
And, Tom Roberts might be able to assist, but I don't believe that there's a scheme at the moment for certification.
Yeah.
Okay. So we'll surely be able to put you in contact with the Watermark guys.
I'd be very keen on that. I actually am part of the the Australian Standard Committee, WS022 Committee, which has been set up for air release valves.
Yeah.
And so I'd be very keen on talking to anyone at, with the Watermark organization, so that we can try and come up with a fair and reasonable standard that means that you're putting in something that's robust and reliable for an important part of the buildings. Yeah.
Sure. So Anne-Marie heads that up, so I'm sure that she'd be happy to receive a phone call and have a chat.
Yeah, be very, very keen to give advice on that. As partial as an engineer, and obviously I have a vested interest being one of the suppliers. But if there's I'm sure there's many people involved in the committee, and I'd love to be part of that if that's possible. Yeah.
Absolutely.
But right now, our valves, to the best of our ability, have the highest levels of accreditation for drinking water suitability, which is AS 4020, 4956, and WASA appraisals as well. So thank you very much for giving us this opportunity, Tom. Sorry, just wanted to say we really appreciate the support of everyone in the organisation and the committee. Yeah.
Tell us, Colin, just quickly, for domestic hot water services, given that the largest one in a huge building is probably going to be, 6 odd litres per second and 100 or 150 diameter pipe,
Yep.
What would be the most suitable air release valve to pop onto that system?
Yeah, look, really, it's the whole thing is that if we're only worried in a hot water system about basically ensuring that we release entrapped air, the Ventolo ST is a very, very good option in a hot water circulating system. It's more compact, it's lighter in weight, it's smaller in height, and it's going to do that. Now, it's not going to be the best option to fill and drain the network, but realistically, you don't really do that very often. Whereas, on the other product I was referring to, this one here can handle hot and cold water, and is more designed for the larger buildings, and is also for cold and hot water, but is important for big networks. So this is going to assist on any plumber filling a network up to, like we would normally use this size valve, to give you a bit of an idea, on a transfer pipeline of up to maximum 150, 200 mil pipeline roughly. So on a building, this would be easily suitable for that without any qualms.
Building, yeah.
Yeah, no qualms at all. There's no need to go with anything bigger than that. We have these valves up to 250 millimeter, but this is not what we're talking about. For buildings, 25 millimeters more than sufficient. Yeah.
Cool. And the coating on the actual body of the valve there.
Yeah. So it's a really good point. So one of the things that Luca Bonatti is the owner of CSA in Italy, is that they use an Ascot Nobel fusion bonded epoxy coating that's applied through not through a hand application, but through a fluidized bed system. And what they do is they actually, the thing that is really, really important if you're going to coat a product is that the pre-treatment on it is very, very substantial to ensure that the actual coating properly bonds to the actual valve itself. And if that pre-treatment is not done correctly, it doesn't work well at all. It'll basically come off. And as part of the standard, I think it's for AS 4158, I think it is the standard for the application of a fusion bonded epoxy. This valve is completely compliant to AS 4158, which ensures that the pre-treatment, the actual application, and the testing of the adhesion and everything else is done within Australian standards. To give you some surety in hot water temperature conditions, it's an ASCO Nobel, or I think that's how you pronounce it, is the name of the company who manufacture the powder. I think it's not going to deteriorate if it's properly bonded beyond 75 degrees. It's not going to melt, so I can't remember exactly the exact temperature, but it's something around the upper 70s or something before it becomes a major issue. But if I understand correctly, most hot water systems is about 70 degrees, about the right temperature that most of them run at.
Yeah, the sort of upper limit, 60, 65 is a fairly common temperature.
Yeah. Certainly that's not an issue for the FBE coating, as long as, and I would really strongly suggest, is that if any consultant is going to use a metallic product with a coating on it, make sure it is people can say, look, is the coating approved to AS 4158. The raw product may be, but it's all about the application and the pre-treatment to make sure that it's physically got that approval. Now, to get AS 4956 approved, that's the coating application is part of that process, and it's really critical that it's done inside and out to the correct thickness, application, and performance. You know?
I think that's a really good point, because there's a lot of, from time to time, larger RPZ valves that might go on heated water services, especially in healthcare. And in the absence of the right coating, it does tend to strip off, and yeah, you end up with an exposed valve.
Absolutely, and that's not a good situation at all. Yep. Right.
Any more questions out there? There is one question here. Are they able to be used on solar heated water services?
Absolutely. Yes. Yeah. So they're used. They're used basically in irrigation, in large nursery systems or solar systems and stuff too as well. No question at all. As long as it's within the temperature limitations of it, absolutely, no question. Yeah.
And then service, Colin, anybody could give you a tingle, you'd be able to help them out?
Absolutely, yes. We have over 25 years experience in design. Look, the big thing is, if I can just leave one parting point here, you want to put the minimum number of these onto a building that you actually have to, because it's a mechanical piece of equipment that needs to be designed correctly, maintained and operated. Now, if you were to put one at every high spot, it just would never happen, and it's not practical. So please, at any stage, share a Zoom meeting or Teams meeting or whatever, or send me some designs, and let's talk about, you know, where the best locations to put them are, because putting them there at the key locations is really the key to the success, and understanding how air moves to know where to put them effectively. And that's the experience that we've got. We've got 7 sales engineers, and I'm the product manager for the air release. Happy for anyone to contact me at any time. Name, contacts, and everything else on our website at bearmad.com.au. Yeah.
And the blue valve, as I call it, is quite large, isn't it? So
yes, it is. Yeah.
If you put your hands above you up to measure it, it would probably be 300, 350.
Yeah, I think it's about that. Yeah, I can tell you exactly in just a few seconds if you want to bear with me. It's
so if that was kind of at the top of a riser, if you had an upwards fed domestic hot water system, one would need to leave sufficient allowance at the top of that riser to.
Or the other thing you can do, of course, is just to offset it. So you can actually put a 90 bend on the top and just offset it to the side, and then run it vertically back up again. The dimension is actually, with the strainer inclusive and the bend on the top, it is actually 415 mil, 415.
Okay, that's quite large, yeah.
Yeah, it is, yeah.
Brilliant.
Thanks again. I really appreciate the opportunity to talk. Thanks, folks.
Thank you, Colin.
Pleasure.
So this tends to draw our meeting to a close close. So thank you for everybody who did attend. I'll just jump back to the presentation. So it would be nice to extend out to the group to see if anybody would like to join the committee for the HCAA as a committee member. It's quite easy to do. It would just be an email to inquiries at HCAA, and the committee meets once a month. It's quite interesting because you get a good bit of insight into what's going on in the industry nationally as well, and also gives good opportunity to sort of avoid trips and stumbles that you might only find through experience. Please feel free to extend invitations to friends, relatives, and people who work in the industry to come and join us at the next gathering for the ACT. I'm thinking probably around December time, but the national committee still has to sit and meet and decide on a date for both Sydney and Canberra at the moment. Hopefully at one point in time we'll get to do a face-to-face, which is quite good because it kind of facilitates a little bit of chat time between presentations and the like. The presentations tonight were great and probably a little longer than what we normally do because it didn't need to facilitate that degree of chat time. I was thinking next time around for presentations we might look at erosion corrosion in copper tube and also microbial growth within drinking water supplies, which are two quite interesting topics and go hand in hand. So if you have anything that you'd like to have presented or are a presenter with something interesting and new and innovative, yeah, feel free to get in contact with us. You can get me at technical at HCAA or through inquiries as well. So thank you very much, everybody. If there's any questions, feel free to stay on the line, happy to chat, or I hope you all have a very nice night. Thank you. I might actually just hand over to Nick as well if he's there, just if Nick has anything to say.
I'll jump in for 2 seconds. Right,
Yeah.
is it working? Can you see me?
Yeah.
All right. Yeah, no, that was all I was going to say was, yeah, we're keen to get local Canberrians involved. So Tom Roberts, he's already put his hand up to say he's happy to help out. But yeah, really want to extend that welcome to, yeah, any of the local guys to get involved and, yeah, make it something that belongs to Canberra, that, you know, is part of the national body. So, yeah, if you know someone who couldn't make it tonight, that might be interested, have a chat with them. But yeah, we're keen to get a couple of guys from Canberra involved and giving us feedback so we can, you know, be a truly national body. So yeah.
It helps share knowledge across states and territories, and we're all out there solving the same problem. So let's do it together.
Yeah. Cool. Thanks, Tom.
Thanks, Nick. Cheers, everyone.